Now, welcome back again. Today we are going to talk about variation. Again, variation of the differential equation. What do you mean by variation of parameters? Means that we have a non-homogeneous system, but with what? With constant coefficient. So I'm going to select every single words here. So for example, we have differential equation. We know, for example, if I have y double prime plus 2, let me see, 2 and 2y prime plus y equal to 0. This one is called what? Homogeneous, you are right. Why? Because the other side is 0, right? And if, for example, if I have this here, because we know sometimes happens, we have what? We have function here, like x squared y double prime plus for example, sine of x y prime. Am I right? That one also is homogeneous. But this differential equation is called what? Constant coefficient. I think we use CC for it. Understood? And how about that one? We have a variable coefficients or function. Why? Because here we have variables. So that's why, in the previous section, in the previous session, we say what? We say if we have constant homogeneous, homogeneous differential equation with constant coefficient. When we mean by constant coefficients, we mean that each y or y prime multiplied by numbers, right? That's a constant coefficients. Okay, as well we have what? Higher degree, right? Higher order. And also, when I say higher order, means that instead of just y prime, maybe you have y double prime, y triple prime, and go on. So in this chapter, we are talking about higher order differential equation. Which type? Those one, they are homogeneous. What else? Homogeneous. What else? Also constant coefficient, not all of them, constant coefficient. So we have many property, many conditions, then we can solve by this method. What was the method? The method is called M sometimes, or you can say we are going to use auxiliary solution. For example, I'm going to just write one of them because we have many cases, but I'm going to review one of them for you. If you want to understand the previous section, actually, just you need to review the example number 1. Everything, single cases we have here. So when we are going to solve that one, we are going to change each prime, look at me, 2 double prime, minus 5, y prime, okay, minus 3, y equal to 0. So in the same case, I have 2 or 3 orders, because during the final, you need to recognize which differential equation do you have. Otherwise, you cannot solve it, because maybe you say, I'm going to solve that one by exact, but totally you are wrong. Why? We have higher order. The exact solution was used for what? The exact method was used for the previous one, for first order, not the higher order, as she said. So we are going to change each derivative by m squared minus m minus 3. What did we do? Yeah, so we change each derivative to y, double prime to m squared, nothing with nothing. Understood? Then we solve that one, and we mention how to solve. If you have a linear equation, you can solve it directly. If you have a quadratic equation, we have many methods. One of them is what? Formula, right? Formula, that's good, formula. So we have formula, quadratic formula. Then you can use all of them. When you solve that one, for example, in here, when you solve it, you see m1, we will get, for example, let me say a is equal to 2, b equal to minus 5, am I right? C equal to minus 3. When we solve that one, we got such a result. For example, we say m1 and 2 equal to minus b plus minus, you remember that one, right? So b squared, okay, tell me. Minus 4, you are right, well done. 4, 2, minus 3 over 2a, 4. And the result will be what? For example, we get m1 and m2 minus 1 over 2. And of course, m2 is what? Is 3. So we will get these two results. Depending on the solution, we have three cases. Depending on the solution, we have three cases. When I say three cases, I mean auxiliary solutions. We have YC. If M1 not equal to M2, how we solve them? We say the solution will be C1 e to power M1x, C2 e to power M2x. Am I right? Then here we have C1 is what? Minus 1 over 2x. C2 is what? E to power 3x. Clear, dears? Do you have any questions? Hello? No questions? Good. Now, if we have repeated solution, because you know the solution may be different, repeated or what? Does not exist. But do you need here we see exist, but it's not real number. It's called what? Complex number. Well done. We mentioned that. So for the second case, look at here. The second example in the previous lecture, we have that one. So we got what? M squared, M minus 5 squared is equal to 5. So it means that we have duplicate M, right? So how about the solution? Instead of M1 and M2, no. If M1 equal to M2, we will say YC equal to C1, any one of them. For example, we have 5. We say MX plus C2. We put X here. Why we put X here? This X means that we have a repetition, duplicated, okay? So we have double, same, so 5X. You got it, dears? Clear? Good. Any question? Good. How about if I have a complex like that? If I have my M1 and M2 is equal to 2 plus minus square root of 3i. How about that case? How we solve that one? We see that our solution, we call that one as alpha, a real part, and imaginary part is called what? Is called beta. Understood? So in that case, I say YC equal to, go, have a nice day, bye, bye. So YC is equal to what? E to power alpha x, okay, C1 cosine beta, right? Plus C2 sine beta x. Understood, dear? Then here alpha is 2x, C1 cosine square root of 3 plus C2 sine square root of 3x. Did you get the idea? This is about the previous one. Today, we are going to continue this one. Our solution is the same, but instead of homogeneous one, yes, yep, yes, C2 sine, let me write for you, C2 sine clear? Tamam? Good? Good. Now, today we are going to use variation of parameters. Instead of homogeneous, we have non-homogeneous. So how we solve them? First of all, we need to change to the standard form. Then we are going to solve. So we are going to use variation parameter for what? For non-homogeneous, okay, non-homogeneous, constant coefficient, higher order differential equation. Understood? So we have a method. This method, 50% deep down the solution is like that. We say y equal to yc plus yp. Yp isn't new for you today, but yc is the previous one. The same. So you make it a homogeneous. We solve that one. We see this is the half of the solution. And we are going to use the Wronskian. Then we will get the solution. We say this is the other half. Then we add together. We collect them. Understood? Clear, dears? Any question? Tamam? Good. Yalla. How we find them? How is Wronskian? What do you mean by that? I'm going to solve by the example. Look at all these W. What's a U prime? Right? We have many things, but actually they are easy. How? Look at here. We have this example. If you try to describe this differential equation, you say what? Non-homogeneous, right? What else? Higher order. What else? Constant coefficient, right? So we have 3 or 4 properties, attributes that they have. Then I am going to think about it using variation. It's y, because here y equal to yc plus yp. That's why. Now, how we solve them? We have y double prime minus 4y prime, y double prime minus 4y prime plus 4y equal to x plus 1 e to power 2x. Do you have any problem with it? We have a higher order and homogeneous constant coefficients, right? So, first of all, part 1, I say y equal to, yes, let me say yc. I say is equal to what? To finding yc. I say y double prime. Yes, directly I'm going to ym. Yeah, we don't need to. So, yalla. We make it homogeneous. So I'm going to solve like a homogeneous. Like that one is 0 in my mind. So I will solve it. M squared, yalla, minus 4m plus 4 equal to 0. Am I right? And I know that one is what? Am I right? Clear? Is the complete square. So how we solve it? M equal to what? M is equal to 2. Are you sure? How many roots do we have? Duplicated, right? So I say yc equal to c1 e to power 2x plus x. Thank you. The same. Am I right? Because we have duplicated. Do you have any question about that first part? Hello? No. Then directly after that one, I'm going to use. Yep. Yeah. No, m square, not m square. M. Yep. Because we have, look at here. We have what? We have a square, then m minus 2 equal to 0, so m equal to 2. Clear? Good. Now, I'm going to find w. What's w? W is the Wronskian. It's called Wronskian. And I think in linear algebra, you got it. Solving differential equation by using Wronskian. How? We have two things, two absolute values. It's called determinant of the matrix. We make a matrix like what? Like going to use that one in first column and going to use that one in the second column. And first row, second column. Do you have? Then the second one here is the derivative of the first one. So e to power 2x, derivative of e to power x is equal to what? 2 e to power 2x. Well done. How about derivative of here? Two functions, yeah. X multiply the second one, right? Plus second multiply by 1, first one. Clear, dears? Now, then find the determinant. Do you know what's a determinant?
You have to multiply by...
Yeah, crossing first the kindly. Do you know about the determinant? Raise your hand. Good. So most of you know. If you don't know, I have actually more video to share with you. Okay? Means that we have a matrix, determinant of the matrix. So it's easy. We are going to multiply main diagonal minus second diagonal. Understood? So yalla day is equal to what? E to power 2x multiply 2x e to power 2x plus e to power 2x minus second diagonal 2x e to power 2x e to power 2x. Am I right? This is the first time, that's why I'm slow. So I'll get what? I will get 2x e to power 4x e to power 4x minus 2x e to power 4x. You can see, am I right? So w is equal to what? Any problem? Okay, now I am going to use W1. What's the W1? Means that first column, remove it, change it. So I'm going to put the second column as we have. Okay, dear? Then I'm going to choose here as a 0 and f of x. How do you know? Huh? You know, oh, I got it, okay. Then where's f of x? Here, right? Good. So how we find that one? We put here 0 and here x plus 1 e to power 2x. Am I right? Or just 1x? I don't know. Yes, 2x. X plus 1 e to power 2x. So what did we do? We put, we make a w. After that, w1. Here is fixed, you know how to put it. We use the auxiliary solution. So we put it here. But for here, we put a 0 and here. Understood? We just put it here. You got it? For w2, I'm going to use here as an auxiliary solution. But for here, 0 and there. Understood, dears? So that's why here mentions something that you didn't understand. Now you understand what's 0 and fx, and you know what's the 0 and fx in the w2. Understood, dears? Shall I repeat it? Okay. We bring w from where? From auxiliaries. Do you remember? We put here and here. Am I right? For the first row. How about the second row? We took derivative of here. Am I right? We go the second row and we find the derivative determinant by what? Main diagonal minus second diagonal. Clear? Good. Then what did we do? We find the number. Now it's time to find W1 and W2. What's the W1 and W2? W1 is the same W. I'm going to change to the W. You remember W? It was e to power 2x, 2 e to power 2x. Am I right? So because I want to find W1, I'm going to change that one to 0. First one to 0. Clear? And I'm going to change here to what? To f of x. What's f of x? F of x is the function that make our differential equation to be non-homogeneous. Means that after here, where's that function that I'm talking about it? The other side of the equality, right? The right side. So here we are. Understood here? Clear? So I'm going to put it here, x plus 1 e to power 2x. Okay? Then this absolute value means determinant. So again, main diagonal will give me 0, right? Minus second diagonal, here we are, x plus 1 e to power 4x. So the result of W1 will be minus x plus 1 e to power 4x. Clear? Tamam? Yalla, it's your turn. We are going to use this W later, not now. W2 is what? W2 is W1. E to power 2x, 2 e to power 2x. But the second column, change it to fx. Am I right? Clear? Any question? No question? Yeah. How we find this one? Sorry? There was no x. It was by mistake. Just we have x plus 1. Okay? Good. So how we find this one? We multiply here by e to power 4x x plus 1 minus 0, which is equal to itself. First diagonal minus second diagonal. So second diagonal will be minus. This is 0, sorry. Any question about that one? Clear, dears? Good. Any question? Clear, good. So now it's time to find yp. Yp is what? Yp is u1. u1 y1 plus u2 y2. What's u? I don't know right now. What's y? It was e to power 2x. What was u2? I don't know. What's u2? y2 is x e to power 2x. Where did I bring this one? From the auxiliary solution, yc. So the auxiliary solution is very important. Do not make a mistake. Before solving whole differential equation, I think you need to check auxiliary solution 2 times. Because if that one is wrong, everything will go to the hard and wrong. Understood? So carefully, when you find yc, be careful. Very, very be careful. Understood? Good. So what's u1 and u2? That's the question. So u1 prime, look, you say in your book, u1 prime is integral of w1 over w. How about u2 prime? Exactly, integral w2 over w. So let me do it one by one. y1 prime, at the beginning you make you dizzy, but later you see it's easy. 2 examples, no more. Just solve 2 examples for me, you'll be fine. No worries. You can answer all the exercise. I agree about that one. I am sure about that one. Sorry, what was the W1?
W1 is minus x plus 1 to the power 4.
Minus x plus 1. How about W? Tamam? Do not multiply, do not do anything. Just be patient till the end. So I'll get what? Am I right? Then u1 prime is equal to minus x squared minus x. Finding the integral, I'll get what? Of course, u1x will be minus x cubed over 3 minus x squared over 2. Clear, dears? So we find y1. How about u2? Of course, u2 prime equal to w2 over w, which is equal to e to power 4. How about w2?
W2 is equal to 1 over 4.
No, w. Yes, w, W. Yep. So where's the w2? E to the power 4x, x plus 1. E to the power 4x, x plus 1. You got it, dears? So then we will get what? X plus 1. So u2 prime equal to x plus 1. How about u2? Means that integral both sides. Clear. So tell me about yp. Just only yp equal to what? We say that u1, right? u1 y1 plus u2 y2. Yalla, u1 sanbu equal to what? Sorry. Minus
minus x squared over 2.
Over 2 multiply e to power 2x. Am I right? What's that? is the auxiliary solution from YC. What's that? It's a particular solution. It's called particular. So we have an auxiliary YC and YP particular solution. So tell me about Y equal to what? General solution. Yeah, Y equal to YC, YP. Am I right? So yes, you can see C1 e to power 2x plus C2 x e to power 2x plus it's long and make a time, but actually when you solve a lot, you are not stopping for what would you do, where's what W1, you'll be faster. Clear, dears? So can you solve that one for me? Here's the solution. Look, here's the old solution, YC and YP. Can you solve that one for me? Just YC, find YC, kindly. Yalla. Just find YC. Example 2. It looks like hard, but actually when you are solving, it's very easy. Post. Yalla. What did you do, Yalla? Tell me. Dears? Yalla. How is YC, Yalla? 4y double prime. We have 4y double prime, okay, plus 36y equal to cosecant, right? 3x. Yalla. How we solve it? First, you need to standard. Yeah, careful. You need to divide by 4. So you will get y double prime 9y equal to 1 over 4 cosecant 36. That's the first step. The second step, we are going to find YC. So I'm going to say m squared plus 9 equal to 0. Then m equal to what? Plus m squared equal to 9 by minus. So m equal to what? Plus minus 3i. So it means that alpha 0, beta 3. Am I right? No. So how is the solution? I say YC equal to e to power alpha, which means e to power 0, which is equal to 1. So C1 cosine 3x plus C2 sine 3x. Because if I have, for example, x plus iy or minus iy, so here's alpha, here's beta. When I have 2 plus 3i, means that alpha 2, beta 3. But when you have only I, but alpha is 0. Understood? Good. Clear? Good, dears. Question? Good. Now, depending on here, I am going to make W. Yalla. Help me. يا جماعة. Cosine 3x. Sine 3x. Yalla. Derivative of cosine 3x. 3 cosine 3x. Am I right? Understood, dears? Good. Now, W is equal to what? Here's here. So 3 cosine square of 3x minus, multiply minus plus 3 sine square 3x is equal to what? Yalla? 3. Why? Because cosine square plus 1 square is equal to 1. That's why. Now, good. That's easy. It's not hard. How about W1? Okay. How about here? 0 of what and what? 1 over 4 cosecant, right? Because we changed it to standard form. Careful. Tamam? Yalla. Equal to what? Minus 1 over 4. Why? Because I know cosecant equal to what? Cosecant multiply sine 3x. And I know that one is equal to what? 1 over sine 3x multiply sine 3x. And this one will remove, and I'll get minus 1 over 4. Our W1. How about W2? Yalla. We have cosine 3x, 3 sine 3x, 0 and 1 over 4 cosecant 3x. Am I right? Okay, yalla. Multiply ka. You'll get, sorry, this is not cosine, cosecant. Cosecant, okay. I'll get what? 1 over 4. You can say tan, you can leave it up to you. Right tan, if you like it, right tan. No, cotan. Cosine over sine, right? Careful. So cotan 3x, or you can leave it. If you don't know, leave it as we have. Cosine multiply cosecant. Clear, dears? Do you have any question? Kindly let me know. No. So now is u1 prime. We say is equal to what? Was equal to W1. It was 3. I remember, right? Yes. W. Yeah, W3. W1 was equal to 12. Am I right? Hello? How about U2? So how about U1 equal to what? Clear. We took an integral to both sides. Now, how about U2 prime? W2 over W was equal to W2 1 over 4 cotan of what?
3x.
3x. Okay. Now, have you solved that one? Huh? U du? This integral? يلا يا جماعة. Derivative of here equal to what? Derivative of sine? Huh? Is equal to 3 cosine secant. So I'm going to put it here like a balance, right? So derivative of denominator exists. So which method we should follow it? Len, of course. Len of cosine, we put 3 here. Cosine, sorry. Yes. Sine 3x. Am I right? Why 3 sine 3x? Clear? Any question? Good. Now, what else? What else? YP. So YP is equal to what? U1y. So where's U1? It was
U1 is minus 1 over 12x.
1 over 12x.
Not the y1.
What was y1? Of course, cosine 3x plus u2 multiply sine 3x. How about y? Just add them. Auxiliary particular. You can see from here. Everything's clear, I think, here. And you got that result. Okay, dear? Do you have any question? That's our solution. Our solution here. And of course, y. Any question? Okay. Shall we take a rest for 10 minutes? Okay. Okay. Welcome back again. So how we solve this example? Of course, we are going to use first what? Auxiliary one. So we have m squared minus 1 equal to 0. So m is equal to minus plus 1. Am I right? Then that's all what we have. We have minus plus 1. And here's auxiliary solution. But sometimes the integrals are not easy, are not elementary. So when we find W1 and W2, we got minus 2. When we find W1, we got that one. So integral of that one is not easy. Integral of U1 is not easy. As well, integral of U2 is not easy. So in that case, sorry, we are going to leave the example. Okay? Even during the exam, I'm not going to bring something like that, of course. I need someone solve them. But if in case in the exercise you found some things that integral are not elementary, need computer, need another stage of the, for example, like another level of the student, so we are leave it like that. So YP, this is the C1 and C2, and there's the result. Do you have any question? So this one is not actually just for understanding. If you face some case like that, it's okay. Sometimes you should stop. But during the exam, 100%, I'm going to bring something that's easier for solving. Now, you can see we solve for 2W, W1 and W2. How about if I have 3? Right? How about if we have 3? What do you mean by 3? Because in the previous lecture, we mixed the 3 cases, if you remember. For example, if M1 equal to 1 and M2 and M3 equal to C1, we say equal to 2 plus minus I, 3I. So how was our solution? Can you tell me? Yeah. Okay.
We have C1 equal to 3x plus
Sorry. For example, you have 4i. So in that case, yc it will be what?
C1x
C1 e to power x. Let me change that on to 5, okay? To be recognized. Plus C2
3 power 3x
e to power
3x
3x
cosine
C2 cosine 4
plus C3
plus C3
sine.
sine 4x. What did we do? We have two cases, right? That one alone is equal to what? And that one alone is equal to what? Understanding. If I have only M2 and M3, how we solve it? If I have just only one, I say C1 e to power alpha, right? We say that one is alpha, that one is beta. Do you remember? So we say e to power alpha x, C1 cosine beta, C2 sine beta. Am I right? Clear? Do you have any problem? But now I have another one, another root. So this one's case 3, that one's case 1. Together it will be what? Case 1. So I will get what? Another solution. We say C1 e to power 5x. So we change, in our mind, we have M1 5, M2 3 equal to 2 3i. It was something like that, for example. In that case, or 3 4, in that case, we say that one is group number 1, group number 2. I'm asking myself, group number 1 with the group number 2, they are equal? No. So I have two cases. I have C1 e to M1 and C2 e to G2. But G2 is what? Group 2 is what? It's another case. So we mix it. Kindly review the previous video, you understand more. Okay, we solved two examples. Clear? Tamam? Good. So now in case we faced such case like that in here. When I say in here, I mean with a non-homogeneous case. How we solve it? How's the way? Yalla. We have 3w, of course. Like what? There's no example, right? So I'm going to solve example 25 for you to understand. And kindly try to solve it at home again and again, okay? Understood, dears? Yalla. How we solve it? We have in exercise y triple plus y prime tan of x. Yalla. So tell me about m. Am I right? So m equal to 0 or m squared equal to minus 1. So m squared is equal to m. M equal to what? Plus minus. Okay. Am I right? Where's alpha? Where's beta? Right? Kaka? Okay. So yc is equal to what? I say c1 e to power 0 plus e to power 0 c2, am I right? Cosine x c3 sine of x. Then c1, c2 do you have any problem with the YC? Do you have a problem? clear? Hello? Now, how we solve the Wronskian? We have W. We have what? Here's 1. Am I right? Here's cosine x. Here's sine x. So derivative of 1, derivative of cosine, derivative of sine, derivative of 0, again 0, derivative of here, and how we find, yes, how we find the determinant of 3 by 3 matrix? Yeah, we choose one of them and we see it's positive, negative, negative. Why I choose 0, 0? Why we choose 0, 0? Because 0 is easier for us, right? You can use that one method or that method. Do you know about that one? Where did you learn that? Not you, the others. Linear algebra, good. So you have a linear algebra. Good. Linear algebra, good, very good. So tell me about the way. Is equal to what? So equal to, we are going to choose 1, then yeah, of course, this matrix, multiply that one. So minus by minus plus, sine by sine, sine square. Minus by minus plus cosine by cosine, cosine square. So sine square plus cosine square, 1. Clear? Dears? Good. Now W1 equal to what? Yalla? We say equal to cosine minus sine minus cosine. Sine, cosine minus sine. Am I right? How about here? 0, 0, f of x. What was f of x? Tan of x, I think. Right? Good. You got it here? So how we multiply that? I'm going to, how we find this determinant? I'm going to use this tan. Then we eliminate here. So cosine by cosine, cosine square, minus by minus, it will be plus, sine by sine, sine square. So I get what? Tan of x. Clear? How about W2? One zero 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 tan sine cosine minus sine. Sorry for not writing a lot because you know. Yalla, how we solve that one? Again, is equal to 1, 0 by here, 0 minus sine. I'll get sine of x. Why? Because cosine multiplied tan is equal to what? Is equal to sine. Sine over cosine, cosine, cosine remove, it remains sine. Shall I repeat it? You got the idea? Good. Now the last one, W3. 1, 0, 0. Am I right? Cosine minus sine minus cosine. Am I right? 0, 0. Tan. Column by column, we're shifted. Then again, I'm going to use 1. Sine by sine. So I'll get what? And 0. So minus sine of x multiplied by 10. That's W3. Do you have any problem? Maybe during the exam, some of them Some of the example like that. This is especially for final because you have a time. Clear, dears? Of course, yalla. We need y1, y2, u1, u2, u3. So u1 equal to what? W, it was 1. How about W1? Tan. Okay, tan. So integral of tan equal to what? Am I right? Also, you can write what? You can write ln of second. You can also write like that. Up to you. Okay? You can write u1 equal to ln of second. Feel free for both of them. Why? Because tan equal to sine over cosine. Derivative of cosine is minus. That's why we put the minus. You have both. Both true. Correct. Understood? Good. That's the first. How about u2? I know w2 over w1. Sorry, w. And I know w is 1, so I'm not going to write. So it's equal to what? To a sine?
Yeah.
Sine. So u2 equal to what? Cosine. Am I right? Good. Finally, it wasn't hard actually. Finally, u3 prime is equal to minus sine tan. Am I right? u3 minus sine tan. Maybe with the mistake by a minus something, it's okay. Yalla. Why? No, integral sine is cosine. Integral sine, you are right, you are right. Thank you. Sorry. Okay? Yalla. How about that one? How we solve this integral? So u equal to what? u3 integral of here. Am I right? How? How you linearize it? Mm-hmm. You mean 1 minus cosine 2x over 2. But if I change that one to that one, how we solve the cosine of here? Cosine 1x, not 2x. If it's 2x, it was easier, you are right. That idea is good if we have cosine 2x in new denominator, right? But here we don't have like that. So, yalla. Okay. I'm going to write like that. If you understand, say okay. If you don't, let me do it for you. Am I right? Clear? No? Cosine square plus sine square equal to 1. So about sine square is equal to 1 minus cosine square. Now clear. Right? Good. What else? This cosine is the common denominator. Am I right? Has the game multiply shaking? So let me multiply by a minus. I'll get what? Am I right? Everything is clear, dears? We multiply by minus. Then I distribute the common denominator for both of them. Why? Because that one will be cosine of x. That one will be what? second of x dx. Clear? Integral of cosec cosine? No, sine. Okay. Integral of secant? You know why? Why? How? يلا. Second of dx is not solvable directly. So we are going to multiply it by this. We bring this one from our pocket. Why? Because when you multiply it, am I right? Derivative of secant tan. Derivative of tan, so derivative of denominator exists in numerator. So it's equal to what? Ln of denominator. That's why we have ln of denominator. It's like it's cal one. Maybe you forget. It's okay. At least you remember. Right? Clear, dears? Then yp, I'm going to leave it for you. We have 3 parts. Understood? Do you have any comment? No comment? No like? Huh?